In this lesson, we're going to talk about factoring polynomials. We've already talked about factoring quadratics. So our directions now might say factor completely. And don't forget that we already know there's a bunch of different types of factoring, but factor completely means get to a point that cannot be factored any further. So now we're going to be dealing with higher powers, right? Powers bigger than quadratics, which means we're going to have more factors within it. So we have to keep going till we find all the factors. So the first thing we do, we check for GCF, right? That stands for greatest common factor. If it's a quadratic in standard form and there's no number in front of the x squared, we just rewrite it, right? The two numbers that multiply to c and add to b. If it's 4 terms, we factor by grouping. If it's standard form quadratic, but there's an a in front, find the a times c first, then do it as 4 terms and factor by grouping. And then there's some special patterns, which are only 2 terms. And we're going to have 3 of those. You already learned about the difference of squares, or difference of 2 squares, dots. Now we're going to talk about difference of cubes and sum of cubes. So this one is factor completely. I only have 2 terms, but it's not cubes or squareds or anything like that. So I'm just going to look for a GCF. The biggest number out of 14 and 7 that we could pull out is 7. There's an x to the 8th power and an x squared. So x squared can come out. And then there's a y to the 5th and a y squared, so y squared can come out, right? We always take the lower of the numbers there. So if I were to divide this whole thing by 7x squared y squared, 14 over 7 is 2. 8 minus 2 is 6. 5 minus 2 is 3. Minus. Now if I divide this by 7x squared y squared, 7 over 7 is 1. X squared over x squared is 1. Y squared over y squared is 1. So it's minus 1. There's one here for you to try. You can pause. Answers are posted in the blank notes in Google Classroom. So our difference of 2 squares, if it's something squared minus something squared, is going to be a plus b times a minus b. They could have variables on both. It could be just numbers. So our perfect squares, right? So like 1 squared is 1, 2 squared is 4, 3 squared is 9, and we can keep going through all of our perfect squares. So 36, 49, 64, 81, 100. So that's up to 10 squared, right? Then we have 11 squared, 12 squared, 13 squared, 14 squared, 15 squared, 16 squared, 17 squared, 18 squared, 19 squared, and 20 squared. You don't necessarily have to memorize them, but you should recognize perfect squares when you see them, especially these bigger ones. It'll help you out when you're seeing a problem that is the difference of 2 squares. So we're going to factor these completely. We have 2 terms. 9 is a perfect square, and x to the 4th is even, so that's a perfect square. 49 is a perfect square, and 2 is even, so that's a perfect square. So I'm going to figure out what was being squared in each place, right? So what was being squared here? 3 was being squared to give us 9. X squared was being squared to get us to x to the 4th. And here, 7 was being squared to give us 49, and y was being squared to give us y squared. So if this is our a term and this is our b term, we would have 3x squared plus 7y and 3x squared minus 7y. Now this is not perfect squares. It's a difference. It's 2 terms, but 3x squared and 7y are not perfect squares. So this is as far as I can factor this one. In the next one, 72 is not a perfect square, 2 is not a perfect square, but I do have a GCF, right? We can take 2 out of both of these. So if I take 2 out, I'm left with 36x squared minus 1. 36 was a perfect squared, and x is a perfect squared, right? X squared is a perfect squared. And this is just 1 that was being squared. So it's 6x and 1. So that's going to be 2 times 6x plus 1 times 6x minus 1. There's 2 for you to try. You can pause, answer the post-it in the blank notes on Google Classroom. So example 3, we're going to factor completely. This is a quadratic. There's no number in front of the x squared, so we're just looking for the numbers that multiply to 144 and add to negative 24. So since this was a positive, we're going to go negative and negative, right? So negative 1, negative 144, negative 2, negative 72. And we're going to keep making our list until we eventually get to negative 12, negative 12. And oh my goodness, that's the one that adds to the negative 24. So this would be x minus 12 times x minus 12. But the easier way to write this, right, something times itself, is squared. So I could actually write this as x minus 12 quantity squared. In B, I have 3 terms. There's no number in front of the highest term, but it is x cubed. But I notice all of them have an x. So we'll start by taking out a GCF of x. And now I have a quadratic. So I'm going to look for the numbers that multiply to negative 5, that add to negative 4, like 1 and negative 5. So this would be x plus 1 and x minus 5. Don't forget the x that we originally pulled out. Some more together. So for this one, I have a number in front of the x squared, and I cannot take it out of everything, right? 3 does not go into 14 evenly. So there is no GCF in this problem. I'm going to have to do it where I take 3 times negative 24, and I get negative 72. And then I'm going to look for the things that multiply to negative 72 that add to positive 14. If it's positive, I know the bigger number is positive. So like negative 1 and 72, negative 2 and 36, negative 3 and 24, negative 4 and 18. Oh my goodness, that adds to 14. So we're going to rewrite this as 4 terms. 3x squared minus 4x plus 18x minus 24. And we're going to split it down the middle. So these two, just an x comes out. We're left with 3x minus 4. For these two, what goes into both 18 and 24 is 6, right? A positive 6. So 18 divided by 6 is 3. Bring the x. Negative 24 divided by 6 is negative 4. These match. That's what we want. So we're going to have 3x minus 4 and x plus 6. For D, I have 3 terms again. I'm starting with an x to the 4th, but I don't have a GCF to take out. As long as the middle power is exactly half of the even first power, we can treat it as if it's quadratic. But instead of using x's, we're going to use whatever half of this was. So we're going to use x squareds instead of our x's. So that means I'm still going to find the 2 numbers that multiply to negative 24 that add to positive 2. Right? If we go through, negative 4 and 6 is it. So instead of writing x minus 4 and x plus 6, it's going to be x squared minus 4 and x squared plus 6. And now this one's interesting because I can go further. X squared minus 4 is a difference of 2 perfect squares, right? This was x being squared, and this was 2 being squared. So this part can really be x plus 2, x minus 2. And x squared plus 6, because it's not a difference, it's plus, can't go any further. So I can just write that factor at the end. There's some here for you to try. You can pause, check your answers when you are done. So something new. This is finally something different than anything we've done before, the sum and difference of cubes. So just like there are perfect squares, there are perfect cubes. And I'll make a list of up to 10 cubed because it gets very big. So 1 to the 3rd power is 1. 2 to the 3rd power is 8. 3 to the 3rd power is 27. 4 to the 3rd is 64. Then we have 125. We have 216. 343, 512, 729, and 1000. Again, these don't have to be memorized, but it is helpful to recognize when you see a perfect cube. And when you have something cubed plus something cubed, or something cubed minus something cubed, we can factor that in the following ways. If there's a plus in between, it's going to be a plus b to start. and it's a squared minus ab plus b squared. If it's a difference, it's going to start with the minus, a minus b, and then this one's going to be the plus, a squared plus ab plus b squared. So for each of them, there's only one negative involved. If it's plus, it starts with plus. If it's minus, it starts with minus. And then the next sign would be the opposite. So for example 4, we have x cubed, which is just x being raised to the third power. And we have 27, which is 3 being raised to the third power. And it's a minus in between. So this is our a, and this is our b. We're going to start with x minus 3. Then it's going to be the first term squared. Now it's plus the product of these terms. So x times 3, or 3 times x, I'll write 3x, plus the second term squared. So 3 squared is 9. And that is my factored form for x cubed minus 27. For b, this is x being cubed, and this is 6 being cubed. And there's a plus sign in between, so that means we're going to start with the plus, then first term squared, now it's minus, product, plus last term squared, 36. Some more together. So this one, 4 and 32 are not perfect cubes, but there's a GCF, right? If I took 4 out of both of those, I'm left with 1 minus 8x cubed. And now 1 is 1 being cubed, and 8x cubed is really 2x being cubed. So the 4 is going to stay on the outside. Now it's minus, so 1 minus 2x. Then 1 squared is 1, plus the product of these, 1 times 2x is 2x, plus the last part is really that 2x being squared, but I'm not allowed to leave it like that. I can just simplify that. So this would be 1 plus 2x plus, and this 2 squared is 4, x squared is x squared. All right, for our last one together, again, 24 I don't recognize as a perfect square, so I'm going to look to take something out, plus they both have x's. So we know we're going to at least take out an x. And then I know 24 is divisible by 3, and 375 is divisible by 3. So let's try taking that out and see if we end up with perfect cubes. So 24 divided by 3 is 8. Now x cubed plus 375 divided by 3 is 125. And yes, these are both perfect cubes, right? This is really 2x that's being cubed. This is really 5 that's being cubed. So I'm going to show plugging it in, and then I'm going to show simplifying it, right? So we took out the 3x. This is a plus sign, so we'll start with plus 2x plus 5. Then the first spot squared minus the product of those two terms plus the last spot squared. So this is going to turn into 4x squared minus 10x plus 25. So here's some for you to try. You can pause. The answers are posted on Google Classroom. All right, example 5, we have 4 terms, so we're going to factor it by grouping. So that the first 2 in x squared would come out, and I'm left with x plus 5. We always want this to be positive because that's always positive, so I'm going to take a negative 4 out of these, which leaves me with x, and then negative over negative plus 5. So lovely, they matched. And we're left with x squared minus 4. But again, x squared minus 4 can go further. That's the difference of 2 squares. Right? Those are the things being squared. So this would be x plus 5, x plus 2, and x minus 2. One here for you to try. You can pause. Answers are posted in Google Classroom. So the factor theorem says a polynomial f of x has a factor x minus k if and only if evaluating the function at that value of k makes it equal 0. So what this means for us is if we know one of the factors or a 0 of a higher order polynomial, we can use synthetic division to factor it out. And then we'll have a smaller polynomial that's left for us to factor. So here, if we are told to factor completely, and we already know that x plus 3 is a factor, that means negative 3 is a solution, and we're going to set this up with our synthetics. So we're going to have 1, negative 13, 15, 189. So remember, multiply, add, multiply, add, multiply, add. And because we knew it was a factor, we should get a remainder of 0 there. So what I'm left with is, remember, 1 power lower, x squared minus 16x plus 63. So to factor this, it's a quadratic, no number in front of x squared, so look for the numbers that multiply to 63 and add to negative 16. That would be negative 7 and negative 9. So when I write my factored form, I need to include the factor they started with. I don't have to start with it, but I need to include it. So those are the 3 factors of this polynomial. All right, so another one, this one tells us that f of negative 7 is 0, so that means actually negative 7 is what's going to go in. We don't have to change the sign because they're already giving us the 0. We have 1, 9, 19, 45, and 70. So multiply, add, multiply, add, multiply, add, multiply, add. So I'm left with x cubed plus 2x squared plus 5x plus 10. When I have 4 terms, my first thought is to try to group it. So out of these 2, an x squared comes out. We're left with x plus 2. Out of these 2, a positive 5 comes out. 5 over 5 is 1x. 10 over 5 is plus 2. And it worked! So my factors that I got here were x plus 2 and x squared plus 5. And then if f of negative 7 was 0, then x plus 7 was also a factor. One more together here. So they're telling me x minus 6 is a factor, so I'm going to put in a positive 6. We have 1, negative 6. There's no x squared term, so I'm going to put a 0 placeholder. Then 8, negative 48. So multiply, add, multiply, add, multiply, add, multiply, add. So I'm starting with x to the 4th in the original, so x to the 3rd. This is x squared, there's nothing. This is x, there's nothing. Then plus 8. So this is difference of 2 cubes, right? This is x being cubed, and this is 2 being cubed. So for this, we would have x plus 2, then first term squared, x squared minus product 2x plus that only squared, 4, and then we can't forget the original, x minus 6 at some point. All right, there's some here for you to try. You can pause, answers are posted in Google Classroom. And of course, we have some word problems. You're given an expression for the volume of the rectangular prism. Find an expression for the missing dimension. So they're giving us 2 dimensions already. And this is a polynomial to the power of 3. So I'm going to factor 1 out at a time. So if I want to factor out the x plus 1, I'm going to take out a 0 of negative 1. So bring down, multiply, add, multiply, add, multiply, add. So I don't need to rewrite this. I know that that's going to be the coefficients of my next one. And now, I already did that one. Now I'm going to take out the x plus 5. So that means negative 5 on the outside. Bring it down, multiply, add. Oops, something's wrong. What did I do wrong? Oh, so that's negative 10. Immediately wrong. Multiply, add. So what I'm left with is if I started it to the third power, this brought me down to the second power, this brought me down to linear. So this would be 3x minus 10. And then one more together. We're going to use the graph of f of x equals this polynomial to write f of x in factored form. So it can't really see exactly where these went through, right? They're not nice numbers, but here it's very blurry on your screen, but negative 3, 0 is a 0 of this function. So we're going to start by taking out that negative 3. So multiply, add, multiply, add, multiply, add. So what I'm left with is 6x squared minus x minus 1. So there's a number in front of the x squared, so I'm going to do 6 times negative 1 to get negative 6. Right? That could be 1 and negative 6, 2 and negative 3. That's the pair it is to equal negative 1. So 6x squared plus 2x minus 3x minus 1. Take 2x out of those. We're left with 3x plus 1. Take a negative out of these. We're left with 3x plus 1. So that means in factored form, we have the 3x plus 1. We have the 2x minus 1. And we have the original x plus 3. And that is now fully factored. And that is the end of factoring polynomials.